Hello to you, wherever you're watching from around Australia or indeed the world, and welcome to the first episode of iNTRO TV, an online event series where we take a look inside the National Transport Research Organisation at our work and how our clients are working with NTRO to solve their transport challenges for great outcomes. My name is Guy Hand. I lead the communications team at NTRO, and it's my pleasure to host our first live online event of what will be a regular series. And today we focus on the unsung heroes of our transport network, bridges and structures. It's often said that a road is just a bridge approach, and in this episode we're joined by a couple of people who would probably agree wholeheartedly with that assessment. NTRO has a dedicated team that works in this space, and we've been doing some important work with the Queensland Department of Transport and Main Roads. And before we get started, we'd like to pay tribute to the teams that have worked on both the projects that we're going to highlight today: Regina Sampaio from NTRO, Carrie Lynn from TMR, Mohammed Nuru Mohammed from TMR, and Gerrit Smit from NTRO. So today we're joined by NTRO's Portfolio Leader for Structures Management, Tatiana Sanchez Castano, who joins us now. Welcome to you, Tatiana.
Thank you, Guy.
And Dr Torill Pape is the Acting Deputy Chief Engineer of Structures at TMR. Torill, thanks for your time and for joining us today.
Oh, thanks. It's a pleasure to be here.
So just a little housekeeping before we get started. Today's session will run for around about 25 minutes, and then there'll be a question and answer session immediately following the presentation. Feel free to ask a question as soon as you think of it. There is a question and answer icon located at the bottom of your screen, depending on how your toolbar is set up. So if you tap on that and type in your question, we'll collate those and ask our experts following the presentation. So Torill, to you first. We're discussing two projects today that TMR and NTRO have teamed up on. That's correct?
Yep, that is correct. Thanks, Guy. So this is, they're actually two of many projects. It was difficult to choose which ones we were going to present on, but it's my pleasure to collaborate here with Tatiana about some of the good work that we've been doing in our research space under our NACO program. Okay, so the first one we have here is all around our management of structures with concrete halving joints. So let's introduce this topic. So the reason why this project came about was, I guess TMR had been doing some work investigating risk on our network. We'd been looking about how we manage bridges in a risk-informed manner and trying to get some clarity on that. And we've certainly improved our processes on that journey. Out of that particular piece of work, we identified that there were components or bridges that were suffering from certain risk characteristics. And then during that process of investigation, there were some bridge collapses. And the first one that happened was the bridge in Lecco. And you can see down the bottom there, that there was the collapses there that made a big difference to us. And we thought, right, we better do something about this. And these were concrete bridges with these halving joints. And certainly we'd taken note of that from the Della Concord Bridge in Canada, which also had this feature. And so TMR, as a rule, we don't allow these types of bridges on our network, but we do have them as legacy structures, and we need to manage them carefully. And there's still some questions around them about how do we manage them and what do we do. And so that just set up the research project that we embarked on under our NACO banner. We have a broader program of work where we're inspecting and looking at how we manage these structures more broadly, but there were some specific research questions that we wanted to ask. Now, these halving joints or Gerber joints that some people might know them as internationally, or depth or depth end joints, they were a feature back in the day. They were aimed at getting extra length out of spans for bridges, or also trying to get a more streamlined effect in terms of an architectural feature. So they were quite prominent back in the day. The problem with these particular joints is that they are linked to being low redundancy. They've obviously got links to bridge collapses, noting that also the Morandi Bridge has some Gerber joints in them as well. And so we identified these as high-risk components. And low redundancy means there's just no alternative load paths to capture where the load can get down to the ground when we've got heavy vehicles. So we've got lots of questions. And they have vulnerabilities that we need to manage. So that's just set up the research project. And so when we start thinking about the objectives and the outcomes when it comes to this research project, really this is about helping TMR understand or improve our knowledge on the behaviour and the structural capacity of these bridges that have these halving joint features, so we can better manage these bridges in a risk-informed manner. And so the outcomes that we're looking for are things like how do we identify these key risks? How do we then recommend the practices for inspection and also structural assessment? And that links also to heavy vehicle access management. And then how do we then develop up effective strategies? And so I'll hand over to Tatiana now, who's going to go through some of the more details of this research. Thanks, Tatiana.
Thank you, Torill, for that great introduction to the project. So I'm Tatiana Sanchez, portfolio leader at NTRO, and I will be taking you through our findings from the project, as well as the benefit that we have identified. So when we started this project, we didn't know how many bridges with halving joints were on the TMR network. So through this research and in partnership with TMR, we identified the types of halving joints as well as the ages of the bridges and the design classes as well. So from TMR's assessment work, we started understanding the bigger risk, what has a problem, what doesn't have a problem, and the key questions that we had, was corrosion an issue in this type of bridges? Is fatigue a concern? How do joints perform when they fail? And what do failure mechanisms look like? So we did extensive research, and we also looked at existing UK guidelines and on managing concrete halving joints, and we add that insights from an Australian context. So we had some data, and that data showed that signs of overstress in certain joints. So based on this, we developed a research program under the NACO program. So here is what we found. So we use computational modeling to simulate how halving joints behave in different type of bridges, like super T-beams, I-girders, and headstocks. So this modeling was very important for our on-site observations, and that helped us anticipate problem areas, understand where cracking might occur, and identify any weak points in the joints under stress. So here on the right, we can see the diagram that show us the expected sequence of cracking in an I-girder with a halving joint. So the first sign that we see here is that inclined cracking at normal service level loads. So as the load increases, so we can see that vertical cracking, and then ultimately we can see that spalling at ultimate level. So we also run a fatigue risk assessment on a monitor bridge headstock with a halving joint, and the results were reassuring. They show a very low risk of fatigue failure, and this tells us that under normal conditions, the structure should hold up very well over time. So it is a positive finding, suggesting that similar structure with halving joints it can hold up very well. So we also, in terms of corrosion, this has not been identified in the test that we perform. However, if you find corrosion in the halving joints, that will be an issue. So for super T girders, the strength of the halving joint mainly depends of how force develop in the strand, and we need to keep an eye for cracks. So our focus should be on two types of cracks. So any cracking at the re-entry corners and those that appear in the soffit, so specifically between 1 to 2 meters from the end of the girder. So quantifying these cracks, it will help us to better understand the girder's performance under stress. So we can see here a screenshot from our finite element analysis at failure level, failure load levels, and that highlights, I just mentioned before, that we need to monitor cracks not only at the re-entrant corner, but also on the soffit. So as part of our findings, show that estimating the capacity of the halving joints could be improved by more precise measurement of the strand development, and this will give a clearer understanding of the joint's strength. So we also run pull-out tests to check the bond between strands and concrete in pre-tensioned bridge girders. So these tests help us to really understand how that strand and concrete work together under stress, which is key to know how strong and reliable these joints are. So the test results have allowed us to improve the computational models that we developed for this project, making them more accurate, and also help us to see how relevant these models are for assessing other structures and extending this application beyond this project. So in this photo here, we can see the arrangement of the pull-out test of one of our girders. In terms of benefits of this project, the key benefit is that provides TMR with a comprehensive knowledge base to better manage risk associated with high-risk bridge families, and it also supports TMR in using best practices for assessing, managing, inspecting, and maintaining bridges with halving joints. So by following these proven methods, TMR can also identify any potential issues earlier, reduce the need of last-minute repairs, and avoid unexpected bridge closures. This proactive approach not just cut down costs, but also help extend the life of the bridges. From an environmental angle, keeping up with the maintenance and extending lifespan can lower the use of resources and reduce the environmental impact. So in summary, this project not only equips TMR with essential knowledge, but also to manage risk more effectively and establish a solid foundation of best practice for ongoing maintenance. So together with these efforts are designed to enhance safety, reliability, and lifespan of critical infrastructure. Torill, would you like to add any of the benefits that this project brought to TMR?
Oh, well, there's been many. I think there've been a lot of questions around how even these bridges perform. And I think we had some very specific questions around fatigue, and it's certainly comforting to see the results of the finite element analysis. And there's been a lot of work. So this has been a long-term major project for us. And it's still ongoing. We're scheduled to complete this project by the middle of next year. And out of that, there will be some guidance on our practice, but it's certainly helping us get very clear about where these bridges sit in our risk profile. And as Tatiana said, that helps us be very proactive in our management strategy, also informs what our investment strategy should be or how we manage this operationally on the network. And what we're finding is that we can legitimately manage these bridges on the network. Obviously, there are some aspects that we need to manage carefully in terms of heavy vehicle access, but still it's been quite a good news story. And certainly supplementing that with our bridge monitoring data, that's been an excellent good news story to help further validate our findings in this research space. So that's been really good. And yeah, watch this space for publications and documentation coming out when we finalise the project.
Thank you. I hand back to you for the second part of the series.
Yeah, so this is our next project. So we've gone from a major project of 4 years plus to something that's probably a little bit more bite-sized, but certainly a need for us in TMR. And this is all in relation to construction vibrations in relation to how do we manage that for the risks to our structures. So TMR, we have a technical a guidance note, TN03, and this is a guideline on ground vibration and air blast practices or safe practices during construction. It includes, but it's not limited to, acceptable levels of vibration from air blast, and what sort of the minimum distance of vibrating rollers that we need to keep to maintain our structures so they don't crack and they don't get damaged. In this particular document, it lacks specific reference to these vibration limits for our structures, namely bridges and tunnels. And so we commenced a bit of a revision on this front, and we got a lot of feedback internally, first of all, and we've also been getting some external feedback that the document is quite out of date. and also how are these limits actually derived? How are they actually justified in the document? Because we have a supplementary table that helps provide some maximum vibration limits, but we have been often challenged on that by industry about the veracity of this particular table. And then also what the international standards are showing from a vibration perspective. We were finding, how do we get some quantifiable data to say what actually correlates to damage that we should be informing, particularly for our contracts when we have developing new infrastructure projects in and around existing infrastructure, and making sure that we're maintaining the integrity of the existing infrastructure. So just in terms of background, particularly for this particular project, is that we're looking specifically at vibrating rollers, and that the construction activities, they do impact our infrastructure. And there's also linkages to pole driving and things like that, and that the impact of the vibrations through the ground does impact our infrastructure. And what does that damage look like? So if we have a look at then what our objectives are, particularly for this research, we really wanted to look at providing some better clarity for our TechNote 03. We wanted to update that to say, well, what is the effective risk management that we should be adopting, and having that evidence-based rather than something that's from quite some time ago, and is there potential changes that we need to update, particularly when you start considering international best practice. Because we don't want to restrict, obviously, development, so we need to be sure about how do we keep things working on site, and we're not just putting numbers out there that are just for numbers' sake, that these are actually what we mean and there are limits for what we need to do. Tatiana, I'll hand over to you for this next one.
Thanks, Tor. So now I'll take you through the key outcomes, findings, and all the benefits of this project. So in this slide, we cover the main updates, including vibration limits, roller classification, and working distances. So with the TN03 guidelines now updated, vibration limits that apply to a broader range of structures. So this means that the guidelines cover different types of buildings and infrastructure. So helping to better protect them from potential vibration damage. So we also updated the classification of the roller groups, as Tor mentioned, to better represent the modern equipment that is used on site. And the minimum working distances have been also revised based on both the current guidelines and the results from field testing. So these distances help us keep construction activities safely separated from nearby structures, lowering the risk of vibration damage. And lastly, we have introduced a traffic light system for monitoring vibrations on bridge construction site. And this color code system make it easy to understand all the vibration levels. So we can see here the couple of tables that we updated and the traffic light system. So we have refined the structures categories to 4 different levels based on updated vibration limits. And this update was guided by all the literature review that we perform, but also with the new field data. Previously, we have 3 categories. But now we have 4, and we have refined that peak particle velocity limits to range from 3 millimeters per second up to 25 millimeters per second. And instead of setting the guidelines based on roller type, now we use centrifugal force to decide the safe distances. And this guideline is also tailored to the type of structure nearby, unlike the old approach which had distance requirements that didn't really consider the specific type of structure. And with the traffic light system, we use it for bridge construction monitoring. So we have as all the traffic lights that the green is good. And green is when we have PPV under 10 millimeters per second. So we continue working as usual. Amber is PPV between 10 to 25 millimeters per second. So we need to pause and investigate why the increase of vibrations. And red, we have the PPV over or 25 millimeters per second, so we need to stop immediately, and you may need to review and update your monitoring plan, and also adjust your working practices. So in summary, this project has helped us to make some real improvements. We have updated now how we handle vibrations to better protect the environment around construction sites, but at the same time, we improve worksite practices and by reclassifying roller types to match the modern equipment, and also adjusting the working distances based on recent guidelines and testing. So all those changes help us to manage better our operations, be more efficient and cost effective, but also while maintaining the safety standards. So a key part of this update was to really find that balance, making sure risk is well managed without putting unnecessary restrictions on constructors. So as Torill mentioned, by refining this NTRO, we want to give a clear guidance that protects nearby structures from vibration damage, but also gives the contractors enough flexibility to work efficiently. So at the moment, the NTRO is draft, is under review, and we will publish soon. Torill, would you like to add anything else in terms of benefits?
Yeah, look, I mean, it just goes to show for this particular project, it was started off as a small idea, but it's certainly been a really interesting one and an interesting journey. We've certainly learned a lot, I suspect, and for us to have an updated document that's got evidence-based engineering in there, that certainly helps us provide clarity, as you said, Tatiana, to our constructors, and also for our contract administrators who are administering contracts on the basis as well. And as you said, Tatiana, at the moment we're in draft mode for this tech note. We're just doing some final rounds of consultation internally, and this will be released externally for comment to our stakeholders, just to making sure that how we're presenting this is right. But it's been a good success story to at least get that next step change. I think out of this as well, we've discovered there's extra areas for us to explore. Certainly in my mind, I've got some big questions around, well, how much is too much, and accumulated damage, and what sort of damage does it really mean, and reflect on to our structures about where you draw the line. So, but that's future work more broadly, but I think this has been an excellent first start to providing clarity. Thanks, Tatiana.
Thank you, Torill, and thank you everyone for listening. Now we hand over to Guy to facilitate the Q&A session.
Thanks very much, Tatiana and Torill. That was it's amazing. Torill pointed out sometimes from very little ideas, big things really happen, and it appears like there've been some wonderful benefits and some much needed benefits that have come out of this work. So many thanks for sharing that with us. We do have a few questions coming through, and just to let everyone know, if the questions, if we find they're going to require a fairly significant or long answer or a more technical answer, we may actually get back to you about them. So feel free to fire those questions in, but if we do have to make a more considered response on them, we will definitely get back to you as well. So I'll start. We do have several questions. So the first one from Siva is about, with the halving joints project, how much do you expect the research has extended the life of bridges that you? That's quite a tricky question, I'd imagine.
That's very tricky. Well, maybe I can give an example from TMR's perspective. I couldn't put a number on it because it's a little bit dangerous to put numbers on things. But certainly with the research and investigation that we've done, what we have been able to do is, for one particular bridge I'm thinking of at the moment, where we've done some instrumentation and we have done some strengthening. So there was a first aspect. But it also, through that data and through some of this investigation, we were able to clarify that we could keep the bridge in service for the next, I think it was the next 15 years, or I think it was 15 years, just while we're trying to figure out what's going on in the network. And that's invaluable to us as TMR from a life extension perspective, because we understand the risks, and that's certainly how we're reflecting on the remainder of our halving joint bridges across the network. Obviously, there's network context. It's not only just halving joints that we have to manage and the risk of halving joints. There are a whole lot of other different risk factors, and also opportunities for network upgrades depending on how the network is expanding and growing. Sorry, it's a bit of a fluffy answer, but at the same time, I think it gives us avenues to explore and say it's not completely off the cards for us to start using the values of this research to say we can keep these bridges in service. And that's a great outcome from a sustainability perspective and repurposing existing structures.
Very much so. Torill, you touched on this one. I might direct this question to you.
Sure.
You talked about the research, and this is the halving joints again. This was you said that you would be finishing the research mid next year. How long has the research taken to this point?
We've been going for about 4 years, just a bit more. I mean, that's just specifically under this particular research program for NACO. We've also had another joint project internally in TMR, and there's also been some other investigation works we've done on bridge-specific sites that's led into this as a research program of works. And I'm sure there'll be more as well. We've got quite a few other things that we want to explore, and if we get the opportunity, some of our bridges that might be replaced, we'd be super keen to go and do some actual site testing, and actually, if we can put it into a test rig and see how it fails. For real, that would be fantastic. So if we can certainly get some research dollars on that basis, we'll look to do that.
Okay. Mentioning NACO brings me very neatly to the next question here, which actually probably I can answer for you. Does NTRO only work with state road agencies? The short answer to that is absolutely not. We work with TMR in large part through the NACO program, which Torill's mentioned. That's the National Asset Centre of Excellence program. It's a multi-year program of works that we do not only in the bridges and structures space, but in a lot of other disciplines as well. Pavements, network operations, road safety asset management, heavy vehicles and sustainability. And we do work with all the state and territory transport agencies as well as NZTA in New Zealand. But we can work really with any organisation that has a transport challenge that they need solved. It could be local government, private toll road companies, mining companies, airport operators, government business enterprises, particularly those in the rail space, public sector companies to startups. So if you have a transport challenge across not just road, but rail ports and airports, we're truly a multimodal organisation. We can probably help, so get in touch. So there'll be some contact on screen at the end of this event, which you can reach out to as well. So hopefully that's an answer for you. This one to both of you, and this again was around the halving joints project from John. Has this info been shared with the National Heavy Vehicle Regulator and with other organisations? TFNSW is one that John's mentioned.
Maybe I'll jump in first, yep. Tatiana, if that's okay. So we have, I'm part of the Austroads Bridge Task Force group. And certainly we have discussed our research previously with our interstate and international colleagues. I know that the NHVR, I'm not quite sure whether it's been shared specifically with them, considering that it's just ongoing research work, but there's certainly that intention that we would share anything that's of value, for example, to the NHVR or any other agency. We're not adverse to doing this. We have published some papers already on this front and presented internationally at conferences. So the knowledge has been started to be disseminated as well. And you can also find some of our research reports on the NACO website as well. So it's free for people to access if they want to see. And of course, TMR and NTRO are very happy to answer questions from people specifically if they've got some specific technical questions or long-term questions.
Yeah, thanks for that, Torill. And Torill's pointed out a great resource, naco.com.au. There's a wonderful series of publications on there, and you can read about any of the reports we've done in any of the disciplines that we've mentioned. It's a terrific resource. Another question from Titus. He's asked, does the structure classification for vibration cover masonry abutments and masonry arch bridges? So that's on the second project.
Tatiana, do you know that one?
We can get back to you on that, but my understanding is that we cover all the structures from the two tables, and bridges is just the traffic light. Yeah.
Sure. Okay, Titus. We will get back to you on that question. We can actually ask some of the people who worked a bit deeper on the project, so we can get back to you with a more qualified answer on that. And one final question here. This is from Satish, and this is about the traffic light system. Why 4 categories? Was that a result of the move to centrifugal force management?
Yeah, the 4 I don't know if Torill has something to add.
Oh, no, you do.
Yeah. But the 4 categories were based on the type of structures that we usually have, or the most common of structures. So initially it was based on roller type, and now in based on type of structures. Yeah.
Excellent. All right. Well, that is that. Actually, apologies. We've got one more question. No, we don't actually. Apologies.
I think I just answered it.
I think you've just answered it there.
I did.
It's fantastic. Well, it's good to know the chat box works.
Yeah, it does.
No, that's excellent. Well, no, thank you so much to everyone for joining us for this session, particularly our thanks to Dr. Torill Pape and Tatiana Sanchez Castano for being our guests on the very first Intro TV. It's been a pleasure to have you both here. We hope we've answered a lot of your questions, and I guess given you a bit of an insight into some of the work that we're doing, and particularly how we're working with clients. It's been a pleasure to have you both on the program. Thank you so much for your time.
Thank you.
Thank you so much.
And for live event attendees, you'll soon receive a feedback survey for today's event. As this is the first of the series, we want to make sure that we make the sessions as relevant to the audience as we possibly can. So any feedback that you give us will help shape what the future of Intro TV looks like. And we'd also like to thank everyone for their attendance at the live event. We'll also be providing case studies of both the projects showcased today. We'll be sending that out to all of those who attended today. So thank you so much on behalf of our presenters today, Dr. Torill Pape and Tatiana Sanchez Castano. Thanks for joining us, and we'll hopefully see you at the next episode of Intro TV.